All right, so today we're learning about transformations on functions. Just so that you know, these are not the transformations you learned in 8th grade. This is not the reflection, dilation, rotation type transformations. All of the addition and subtraction and multiplication that you have performed on functions has an effect on their graphs, and we call those effects transformations. So today we're going to explore a little bit and learn exactly what transformations take place for each operation. So we're going to start off with something called the parent function. A parent function is the graph where we start. So I'm going to start with a graph f of x equals the absolute value of x. So just so that you know where this graph is coming from, the absolute value of 0 is 0, the absolute value of 1 is 1, the absolute value of 2 is 2, 3 is 3, right? But the absolute value of negative 1 is 1, the absolute value of negative 2 is 2, negative 3 becomes a 3, and so on. So that's why our graph looks like a V. Notice that on the right-hand side of the graph we have a slope of 1, and on the left-hand side of the graph we have a slope of negative 1. So it basically just goes from corner to corner on your grid. That'll be important later, and it will help you graph your transformations better. Okay, so I'm going to take you to a graphing calculator, and we're going to put in the function absolute value of x. Whoops, let me clear that out. So I'm going to go to my absolute value function, and I'm going to put in absolute value of x. Notice that that's going to be my blue graph, and when I graph it, it looks like what I had on the paper a second ago, right? Alright, so now we're going to look at what happens when I take my function and subtract 3 from it. So just so you know what it looks like in equation notation, that means I'm taking that absolute value of x and subtracting 3. I call this subtracting outside the function because it's outside of my absolute value brackets. So let's go back to our calculator. And in my red graph, I'm going to put in my absolute value of x, and then outside the brackets I'm going to put minus 3. So now it's going to graph my blue parent function graph, and now it's going to graph my transformed graph in red. So take a look at what that does. If you notice my parent function in blue, and my red function where we subtracted 3 outside the brackets, it basically moved the whole graph down 3 units. It didn't change the shape of the graph in any way. The slopes are the same. Everything is the same except for it just moved it down 3 units. So on my paper right here, we're going to put that moved this graph, if I can get this to show up, this moved it down, or moved my graph down 3 units. Now, what do you think is going to happen when I add 3 outside the function? So outside the function means I'm going to take f of x, which was the absolute value of x, and outside the function I'm going to add 3. This is what it looks like as an equation. Let's take a look at what that does on our graph. So now we've got our parent function in red. We've got the subtract 3 outside the function parent function in blue, subtracting 3 in red. Now in black, let's take a look at what happens when we take our function and outside the brackets add 3. Let's see if it's what you think it is. Is that what you expected? For my parent function to go up 3 units? Again, notice the shape of the graph is identical, slopes stay the same, everything else. We just simply moved the graph up 3 units. So on my graph, adding 3 outside the function moved my graph up 3 units. So what's happening when you add or subtract outside the function? We are moving which directions? Up if you add, right? And down if you subtract. So let's take a look at what's happening to these graphs, right? Just from the equation or from the function notation, we can kind of tell. If I add 4 outside the function, which in this particular case would look like absolute value of x plus 4, what do you think is going to happen to our graph? It's going to go up 4 units. How about if I add 7 outside the function? Up 7 units, right? If I add 3, we're going to go up 3 units. And if I add 2, we're going to go up 2 units. What happened when we subtracted outside the function? So in equation notation, this would look like the absolute value of x, and then outside the brackets I would do minus 8. This is when we went down, so this would move my graph down 8 units. This with the subtract 1 would move our graph down 1 unit. Subtracting 5 outside the function would move us down 5 units. And the last one would move us down 4 units. So you can make your graph point by point, or you can move like the vertex and then use the same slope and stuff like that. It's different if we're using a quadratic function. You don't want to just use the same slope. We'll look at that at a later date. Okay, so now we're going to look at what happens when we add and subtract inside the function. Notice how the plus 3 and the minus 3 are inside the parentheses. So this is going to work just a little differently. Let's start with the plus 3 inside the function. In equation form, I would have my absolute value bracket, and I would put the x plus 3 inside the brackets. Let's see what happens on our calculator. Let me clear these 2 equations out. Let's see. Okay. Now in red, we're going to do the absolute value of x plus 3 inside the brackets. Remember, our parent function is in blue, and our new function or child function is in red. Let's take a look at what happens. Here's our parent function, absolute value of x, and adding 3 inside the brackets moved it which direction? It moved it to the left 3 units. So this one moved us to the left 3 units. Is that the direction you expected it to go? No, not really. I'll explain why that happens in class and next time we meet. So if adding 3 inside the function moved us left 3 units, what do you think is going to happen when we subtract 3 inside the function? In equation form, the x minus 3 is going to be inside our absolute value brackets. Let's see what happens on our calculator. We're going to put this one, let's put it in green. We're going to do absolute value, and inside the function, I'm going to put x minus 3. Which direction do you think that's going to go? Let's take a look. Remember, the parent function was in blue. That's always our starting point. So I subtracted 3 inside the function and it moved it to the right 3 units. So subtracting inside the function moved us to the right 3 units. So inside the function moves us left and right. Left if we add inside the function, and right if we subtract inside the function. So let's take a look at what's happening to our graphs. Notice how the plus and the minus values are inside the parentheses in my function notation. So this would be, for instance, absolute value of x plus 4. Which direction did our graph move if we added inside the parentheses? This would move us to the left 4 units. How about the x plus 7? To the left 7 units, right? To the left 3 units for x plus 3 inside the function, and to the left 2 units if we're adding 2 inside the function. Subtracting moved us to the right. In equation notation, this would be x minus 8 inside the absolute value brackets. That moved us to the right. So this would move us to the right 8 units. Oh, sheesh, this is just having a hard time. If I subtract 1 inside the function, I'm moving to the right 1 unit. To the right 5 units if I subtract 5 inside the function, and to the right 4 units if I subtract 4 inside the brackets. Alright, the last thing we're going to look at today is what happens if there's a negative with my function. A negative creates a whole different scenario for us. So let's take a look. My parent function this time, I had chosen x to the 3rd power. I'm still going to, on my calculator, I'm going to stick with the absolute value for just a minute. And let's take a look at what happens if I put a negative on the outside. In equation notation, that means I'm going to put a negative outside the brackets. Let's take a look at what happens on a calculator. Let's go back and clear the other functions out. Okay, my parent function is still in blue. Okay, that's our absolute value of x. And in red, we're going to put the negative on the outside. Make sure to use negative instead of subtraction. We're going to do negative absolute value of x. Remember, our parent function is in blue. Our new function will show up in red. What happened with our new function? What's the difference between the blue and the red? The red is simply upside down, right? The vertex did not change. I want you to notice that. The vertex did not change, but all of the y values went from a positive value to a negative value. So all the y values changed sign. Why did that happen? Because what does f of x replace? F of x replaces y. So this is saying to take the opposite of all the y values. So our graph basically turned upside down. Now let's take a look. Well, let's write that down first before we move on. Let's put this on here. This is upside down. Oop. Or we could say take the opposite of all y values. Okay, the opposite of all y values, which basically turns your graph upside down. If you look at the x to the third function, right, it's upside down now too. All the y values went from either negative to positive or from positive to negative in our new graph. Okay, last but not least, let's take a look at what happens if I put the negative inside the function. So in equation notation, the negative is going to be on the inside. Let's look at what that looks like on our calculator. Back to y equals. I'm going to clear out that red function. So now I'm going to put the absolute value of negative x. Okay, the negative is inside the function. Let's look at what happens. Okay, now that's why we probably shouldn't use an absolute value function to show this problem, but it actually did change. Even though in this case the graph basically drew the second graph on top of the first, that's not really what happened. If you go back to our x to the third function, it actually does change. How is it different between the parent function and its child? It does the same thing. It flips, but this time it doesn't flip upside down. It's a reflection. So I kind of lied a little bit earlier. It is one little portion of your 8th grade transformations. This is a reflection across the the y-axis, whoops. And if we want to get really technical, this other one was a reflection too. This was a reflection across the x-axis. The other one is a reflection across the y-axis. In other words, we take the opposite of all x values. That's an x. Sorry, my handwriting really is not this bad. For some reason, the slate just is really hard to write on. So opposite of all the x values, all of my x values are now on the other side of the y-axis, right? This point came over here, right? So you take the opposite of all your x values, the y values stay the same. Up here with the pink, the x values all stayed the same. So you need to kind of memorize which negative flips you upside down and reflects across your x-axis, and which negative flips it across, does the mirror image on the side and reflects you across the y-axis. So what happens when we add outside the function? Let's just kind of wrap this up here. When we add outside the function, we went up. When we subtracted outside the function, we went down. When we added inside the function, we went to the left. When we subtracted inside the function, we went to the right. When there was a negative outside the function, we reflected, oh heavens, across the x-axis and changed all our y values, right? Took the opposite of all your y values, x values stayed the same. And a negative inside the function reflected across the y-axis and changed the value or changed the sign on all your x values, and your y values stayed the same. Okay, we'll practice doing this with all kinds of graphs. You can have more than one transformation time. We'll talk about that in class too, so kind of ignore that part at first. Remember to write down all the questions that you have and bring them to class. I hope you have a great day, and I'll see you next time.